Hi, my name is Nate, and welcome to another potentially exciting episode of Outside the Vacuum. I know it doesn't look like it, but this piano's really come a long way since we cracked it open in October of last year. I feel I can finally see the light at the end of the tunnel. Today, we'll overcome the largest hurdle in the entire project. Or we'll try. Let's go. Alright, this is the big one, folks. The episode no one knew they wanted. Today we'll be looking at the valves of our player piano. The valves control the bellows that play the piano action. These valves are quite a unique technology. The valves are like the player piano valves are like... How do I describe... Let me see what I've got for spare parts we can do a little demo with. Whew! That was almost as bad as one of those Galbransons. Yeah, not too bad for having my eyes closed the whole time. Now we can talk about valves. We'll start from the top down. This is our primary valve chest. The section outlined in blue, when the player is in use, is always under vacuum. The first point of interest in this system is the signal tube. Currently, this signal tube is closed off. This would be when the piano roll is covering the hole that this tube is connected to in the tracker bar. With this hole closed, not only is this section under a vacuum, but so is this channel here. This channel is connected to vacuum because of this bleed cup. This bleed cup has a tiny metered hole, a hole that is much smaller than the hole in the piano roll or the tracker bar. A hole, of course, still big enough for vacuum to get through. This bleed equalizes the pressure on our pouch. The pouch is this leather membrane here. Once the signal tube opens, this pouch inflates with high pressure atmosphere. When that pouch inflates, it opens this primary valve. When the valve is in the open position like it is now, it opens a port here at the top that connects this channel to atmosphere. This creates an amplified signal. Again, we have our signal hose, which is now open, coming from the tracker bar, allowing high pressure atmosphere into this channel, lifting the pouch, opening this primary valve, allowing a larger amount of air than can pass through the piano roll into this amplified signal channel. When the hole closes in the signal tube or in the tracker bar, the bleed vents out all this high pressure atmosphere from this channel and from underneath the pouch. This allows the valve with gravity and some suction to close. The valve now closes this port off. We are no longer getting high pressure atmosphere through this amplified signal channel. It's now connected to suction via this port here. So when the valve is closed, this is closed off, this is open, and when the signal hose is open, this point is closed off, and this point is open. You can think of primary valves like an electrical relay, doing a big thing with a little thing. Okay, let's tear into our primary valve chest. I'll use a screwdriver this time. Here's those pouches we talked about earlier. You can also see the bleed in the foreground. These leather pouches are well over 100 years old, and at this point are quite rotten and certainly not airtight. I'll replace them all. I've given the pouch board a little time to air out, and now I will seal all the channels with some coats of shellac. It's very important that these channels are airtight. We don't want one channel to bleed over and leak to another channel. This would cause two notes to play when we only need one note playing. While that shellac dries, I'll start tearing down the primary valves so that they can be overhauled. A little heat makes quick work of the old glue that's holding the two pieces of these primary valves together. Each button was originally faced with leather for an airtight seal, but much like our pouches, that leather has rotten and needs to be replaced. With all the primary valves apart, I stripped off all the old leather and sanded the top buttons down to make sure they were nice and flat to receive the replacement valve facings. Speaking of replacement valve facings, let's take a look at that, or check that out or something. Alright, I've got a bubble jar set up here, connected to a quick and simple mock-up of the primary outside valve seat. And I want to do some testing to see what a good material would be to replace the original leather. So I'll fire up the bubble jar. Now this is connected to a vacuum through here, and any air entering, creating bubbles, is coming through here. So here's an original with the original leather. Here's some modern garment leather. But I've actually used this very leather on the piano I record on, the piano you've heard throughout my videos. So I know it works, but that's not the best. And here's a technique that a friend told me about. It's actually silicone and leather, kind of like my fingers. Alright, speed trial. There's the original, there's some modern new leather, and the silicone and leather sandwich. I'm going to go with that one. Here's a closer look at my friend Bruce's technique of gluing silicone to leather. I'm so glad Bruce told me about this. The silicone facing proved to be the most airtight on the bubble jar, and the leather backing allows me to glue these on with hide glue, just like they were originally. Here's a quick and dirty look at how this sandwich is made. The yellow layer is the leather, and I'm attaching it with silicone caulking. I'm spreading out that caulking with this little jigsaw blade. It has very fine teeth, and it's chucked up into a hobby knife handle. This allows me to spread out that silicone in a very fine and even layer onto the leather. Time for the silicone sheet. Then I'll lay this down on a flat piece of melamine, and I will press it overnight with a very smooth piece of old countertop. I think it's slate or marble. I don't really know what it is. I just kind of use it and really, frankly, take it for granted. And let's see how we did. Overall, it glued up really well. I did get some phantom glue boogies on this side. Of course, I'll work around that. Alright, our valve facings are in there. We just got to get them out. Okay, time to glue it to it. As mentioned previously, I'll use hide glue to attach the leather side of the facing to the wood button. Another nice thing about the silicone side of these is that when I inadvertently get hide glue on the working surface, the hide glue will just wipe right off the silicone. While that glue dries, we'll go back to the primary pouch board, which I've got all sanded and cleaned up. That means it's time for pouches. I recently got these pouches from a retired piano technician in a batch of his unused materials. I've never worked with him before, but I'm really excited to try them out. They seem very supple and very airtight. I understand they're a synthetic material, so they should last a lot longer than leather too. I'm just kidding, we're going to use leather. Traditional leather. I can still get pouch leather made for this very purpose. I've got them all punched out and just need to install them. For that, I'll use this special pouch setting tool. It's very important that the pouches have a dish or concave shape. This allows for movement. And this special pouch setting tool helps hold them to the right shape as I glue them down. Alright, let's glue it to it. You'll notice that I'm skipping the first 3 pouches on this deck. I'll skip the end 3 as well. This is an 88 note player, but all the piano rolls in my collection only use 82 notes in the scale. I don't think any true 88 note rolls have been cut since, I don't know, 1912. And while that glue dries, I can start installing the primary valves now that they're completely rebuilt top and bottom. When installing these valves, it's very important that they have the right amount of travel up and down. Too much travel up and down, and they will cause leaks when they're in between the stages of being open and closed. And too little travel won't allow them to open enough to let the proper amount of airflow through. I used to use some homemade cardstock spacers for this purpose, but they were never very fun to work with. So I reached out to Howard Gustafson of Ragland Piano Company. Howard has an eBay store, which is how I got connected with him. Ragland Piano Company sells a lot of replacement reproduction player piano parts that we simply couldn't get anywhere else. Howard was nice enough to work with me on this design for a spacer. It's acrylic and is the right thickness for the right amount of valve travel. Thank you, Howard. They really worked well. Not sponsored, I promise. I know it kind of sounds like it, but it's not. Phew, the primary valves are done. We know that the primary valves create an amplified signal, but where does that signal go? To another pouch. This secondary pouch actuates a secondary valve. This secondary valve controls the position of our pneumatic. The pneumatics are what do the heavy lifting and actually play the piano. When the secondary pouch receives an amplified signal, it moves our secondary valve. In this position, the valve is opening the pneumatic to our vacuum source, which evacuates the air from the pneumatic, closing it. With no signals sent to the secondary pouch, our secondary valve will be in the closed position. It closes off suction to the pneumatic, but opens the pneumatic to atmosphere. This allows the pneumatic to refill with atmospheric air and open with the help of gravity. Let's look at that one more time just for fun. When our secondary pouch receives an amplified signal, it moves the secondary valve, allowing our vacuum source to reach the pneumatic, causing the pneumatic to close. When our signal line closes, suction pulls that valve back towards its inside seat, and the pneumatic is now open to atmosphere. Hope that helps. Back to our project. What do you know? More valves! There are a lot of parts that make up each individual secondary valve. These are the parts that we'll cover in this video, and we'll discuss them as we encounter them. Alright, let's start tearing this down. Here's one, 87 to go. There are exactly 352 screws holding these valves in place, and it takes over an hour to get them all out. With all the screws out, next I'll remove these wood buttons. They're attached to these metal stems. The metal stems are just soft nickel-plated brass, and I don't want to scratch them with pliers. I used some tracker bar tubing to pad the jaws of my pliers so I didn't mar the surface of those valve stems. These are the inside valve seats that the valves seal against. They're stamped brass, which has been lacquered. Either over time or from poor manufacturing, a lot of these brass seats are warped and need to be sanded so that they're flat. Here's one that's really bad. So bad, in fact, that I'll have to swap it out. Since I won't be rebuilding the 3 highest or lowest notes in this stack, I have a few spare parts to work with that are from the same batch as the surrounding parts. I'll be sure to bypass these 3 highest and lowest notes in a way that can be undone in the future with no modifications to the stack. All of these parts that I remove will go in a small box inside of the piano. That way, if someone wants to put it back to the way it was originally, they can. While that dries, we'll look at our next point of interest on these valves, the inside valve facing. Alright, I want to take a look at some of our different options for secondary inside valve facings. I've got a mock-up here of our secondary inside valve seat and our bubble jar. I'll fire that up and we'll see how some different materials compare as far as leakage. Here's an original. Not bad for 100 years old, I'm amazed. Here's some modern leather. It's not meant for player pianos, it's garment leather. But I've had good luck with it in the past, at least using it on primary valves. You see I've got it glued to a disc there. It's alright. It seems comparable with the original one. Here's another sample of some modern leather. This has got a smooth finish on it. I've used it in the past for flat valves. And it's set up in the same way the original one is. It's not glued to anything. Also not terrible. Now here's some silicone. It's very thin sheet. I think it's 1/32. Also set up the same way the original, not glued to anything, just held in place by the washers. That's a really good seal. But I know this doesn't show up on camera very well, at least not from this angle, but I'm having to pull it up quite a bit before it releases. It's kind of acting like a plunger. So I don't think that's a good option. I think it's too flexible. Now here's some thicker silicone, 1/16. Oh, and that's nice. There's hardly any give before it releases. I think that's what I'm going to use. Let's compare that to the original. It's better, but the original is still quite good. I'm very impressed. And some garment leather, not very good. Some flat valve leather, that's okay. Silicone, pretty good. I'm sure a few folks out there think that for using this material, I'm a silly conehead. But I really do not like the idea of using leather on metal parts. And here's why. Here are a couple different secondary valves out of 2 different player pianos that gave their life for science. On both cases, there is corrosion around the outside valve facing, which is leather, and the metal stem. This isn't meant to talk anyone out of using leather for their projects. Ultimately, what I've learned is to experiment, trust my gut, and use what I feel best about. Because no matter what we do, anything's going to be a compromise. But now you know how I feel. That right there, that's the devil's bush. Anywho, now we can get all the secondary valves torn down for rebuilding. The major part of this disassembly involves the use of an arbor press to remove these force-fit collars that help hold all the valve components in place on the valve stem. One. With the force-fit collars removed, I found that they need to be re-tightened so they can be reinstalled and have a good amount of friction to hold things in place. To do that, I'll swage them with this nail set. Fun little diversion here, both the nail set and anvil were my grandfather's. My grandfather worked for the NPRR Railroad, and it seems like a lot of tools followed him home. This anvil, it's 4 inches in diameter. I've always wondered if it might be a section of a railroad car axle. Should have asked him. Too late now. Before we get back to our project, let's check out today's sponsor. Are you tired of that feeling you get when you're sorting your hardware and you're reminded of your disgusting eating habits? Are you fed up with disappointing rebounds? Feeling cornered? Do you feel like the odds are always stacked against you? Just stop. You don't have to. With Tupperware. Tupperware?
Tupper right here. It's a Tupperware party. Colors. No more nasty rebounds. Corners like a dream, because there are none. Feeling wacky? Get stacky. This is a discontinued product, not available in stores. Try eBay. Anyway, I've got all of the parts for our secondary valves prepped and ready to be assembled. Got the wood buttons. Valve stems are cleaned up. The sheet metal washers are also cleaned up. All the force fit collars have been tightened. I've got all new punchings, outside and inside valve facings, new secondary pouches, replacement valve guides, thank you Raglan piano, and replacement valve discs for the outside valve seats. These two will get glued together. Here's the old valve, and here's an overhauled valve. Alright, time to get everything assembled. Just like our primary valves, the secondary valves need to have the correct amount of valve travel. Well, unfortunately with this design, I'm having a lot of trouble setting that travel. Let's take a closer look at what's going on.
This is the outside face. It seals off to atmosphere, and you can see they threaded these so that it's adjustable. You can turn that and change the height.
Here's one of my overhauled valves.
Here it's got good wobble. If I screw it on to change the clearance, it's way too stiff.
Of course, this all comes down to materials application. They originally used leather that was both flexible and airtight, and I really don't want to use leather on these valve stems. So, I'll go to plan C, D, I don't know. We'll do something different. It'll be a lot of work. Whatever. I found a slightly newer donor set of valve stems that aren't threaded that allow me to set them up in a more conventional way. It just meant I had to go through this again, but on another set of valves to salvage the parts. And of course this meant tearing down all of my overhauled valves to redo them. This all comes down to experiment every step of the way. Whoops. Here's the original. Here's my first attempt that failed. And here's plan C. This is an unthreaded valve stem. The height can be changed by putting shims in this space here. Okay, let's try this again. Much better. I'm able to quickly change the gap by changing out shims and maintaining good wobble on the valve. 8 hours later, let's button this baby up. Whew! It feels so good to have all these valve parts back together. That really was a huge hurdle. Thanks so much for watching. Next time, we'll take a look at these Striker pneumatics. Keep your can openers handy.